Hi everyone, and you're watching I Can Code Now. In this video, we will talk about variables and data types in C++. So before we get started on our uh, main lecture, let me just create a new project in this current solution. So as we have discussed earlier, that a solution can contain multiple projects. So in order to create a new project in this current solution, let us go ahead and right click on this solution. I can code now. Your solution name might be different. So just go ahead and right click it and go to add and click this new project option. Then inside this new project window, select this empty project. If you don't see this empty project, you can go ahead and type empty project here, empty project, and then go ahead and select this empty project C++ with C++. Go ahead and click next. Then we will rename it so that it dictates what it contains, and then I will simply click create. So a new project has been created, and we will just go ahead and close this main file because it is from this other project. Let's go ahead and close it and collapse this first project. And then in order to run this new project, we will select this project as our startup project. Such go ahead and right click it and select this setup as startup project. Now whenever we click this button or whenever we run it, this is the project that will run, and it will try to find main in this project. Let me quickly create a new file in this project, and I can go ahead and create a new file by going to new item and rename it main because it will contain our main function. And go ahead and click add. Make sure the C++ file.cpp extension is selected. So this new file is created, and let me just quickly go ahead and right click this tab here and select place tabs on the left. I prefer it on the left. You can place it wherever you like to by selecting all these different options. So let's talk about variables and data types. So variable is something that can variate. So basically, anything in any language in any language, you need to create variables in order to store data, meaningful data, so that the data can be used to do different things. So in order to explain that, let me quickly write this hello world program that we have seen earlier. Alright, I've written this small program, and to explain what a variable is, I can simply type this X or anything, A or B or C. This is a variable, and variable is something that reserves memory for our program. And in order to reserve memory, we create a variable. But how much memory that variable should take in memory? And to specify how much memory it takes, we have different data types. And depending on the data types, the variable might take up different sizes in the memory. So one of those data types is int. So to make this variable meaningful, we need to also dictate how much space it should take in memory. So let me just quickly write int here. Now we are telling it to take int, and to make this variable of type int, and this int is something called our data type that defines how much space is required in the memory by this variable. So int is one of the data types in C++. There are many data types in C++, and all of them can be collectively classified into three types. So one of those is this, built-in data types, yeah, and these are also called, primitives data types, yeah, and there's one other, class of data types, which is the derived data types. So now these are the types that are derived from these primitive data types. So combining these primitive data types. We by combining these primitive data types, we get derived data types. And then there comes the final type of data types, which is the user-defined data types. This is also called abstract types. So user-defined data types are something that are very useful in real-world problems, and these ultimately contains these primitive and derived data types, but we can we have this advantage that we can name these data types as as we want. In this video, we will talk about these primitive data types or the built-in data types, and we'll see further details about these other data types in our further videos. So, there are many primitive data types or built-in data types in C++, and let me just list those here. And these forward slashes or comments in C++. So these will be ignored by the compiler when we run this program. So the first primitive data type that is very common is int, integer data type. We write it as int in C++. And the next one is float data type. We write it as float. And next up is double data type. And this is also called, you know, double float. And but we write it as double. There is this other boolean or let's call it logical data type, and we write it as bool, right? And this final built-in or primitive data type is this character data type, and we write it as char, character. These are the five built-in data types that are provided by C++, and each of these are different in their characteristics, and they might take up different space in memory. Whenever we define a variable, we need to declare two things. One is its data type, and the other thing is its name. Name is something that is uh, that are created for us to read, but the names are ignored by CPU or processor, and they simply work on the memory spaces and things like that. But for us in C++, for it to be syntactically correct, the syntax should be correct. So we need to define the variable which must contain a data type and a name. So in order to define an integer variable, we simply write int. This is going to be integer, and we name it anything. For now, let's call it first. And we must put a semicolon in it at the end of it so that the statement ends. In C++, every statement ends with a semicolon. So we have declared a variable, and I wanted to take the space that is defined by this int data type, and that's it. That's it. I don't want to do anything more in this line, so I just write this semicolon here. Now in the next statement, I can create a float by writing this float, and we can call it second. And similarly, we can you know name the variable anything, and we have these five options or built-in data types to define how much space they should take. So let's get into the detail of integer data type or integral data type. So once we have declared a data type and its name and its variable name, uh, we haven't given it any value. So this statement here simply reserves memory in the in the CPU or the processor, but it does not contain any meaningful value. It might contain garbage value, or some compilers or some operating systems don't allow us to use this unallocated memory space. So uninitialized memory space, we have allocated memory space, but we have not initialized it. So in order to initialize something, we can use this syntax is equal to 1. You know, we have now in this statement reserved some space which is of int size, and I have allocated this one value into that int, into that space. And by the way, these values are converted into binary when it is compiled. So, so in integers, we can only store values that are integers. So it will not contain any integral, any, decimal part. So we can store any type of value here, any number, any simple number. In the real world, we cannot. We prefer, writing comma separated values, but in C++ or in programming language, these are not applicable. We simply write this without any comma or without any spaces. Depending on operating system and the environment, the integer can take up to 2 bytes or 4 bytes of memory. So 1 byte is basically 8 bits, and 1 bit is actually is the final atomic component in the CPU that the CPU understands. So the integer type can only store values which are integral, and they must not contain exponentials. So in order to store those decimal type of values, we have this float data type, and we can store decimal values in here like this. This is this will store 15.99 as it is in this second location, which we have reserved in the memory. We can also write, a decimal point here, but that will be ignored by the compiler because we have said it that it is integer data type, and this will, ignore this part and will store 1000 as it is. And the double is basically a double floating point. In order to store larger floating values, we have this double option. This double basically reserves more space in memory, so we can allocate more larger values. So whatever the size of float is, the double will be the double of that size. For example, if the float data type reserves 4 bytes of memory, the double will reserve 8 bytes of that memory. And the values that we store in double are no different than the values that we store in float. So we can simply rewrite, and so this here will take up more memory than this, although the values are same, but the memory that is reserved is pretty much more than the floating data type. Then there is this Boolean data type. So Boolean is something that is a logical data type. Either something is true or it is false. There is no other value. So we can only store true or false in this Boolean data type. So just let's initialize it with true for now. So true is anything that is not zero. Anything that is zero will be false. So we can also write this as 1 or maybe 99 or 123. Anything that is not zero will be considered true by the compiler and will become true when the program is compiled. So in order to make it false, I can write it false, or we can write 0 here. This will also be false and will be converted into this false value when it is compiled. So the last primitive data type is this character data type. So the character data type will can contain. So the character data type can contain one character that a character is something, anything that is allowed by the language. So in order to store a character, we use single quotes, and inside those single quotes we write that character. So if we want the fifth variable to store, you know, E character. This will contain E value, and a character is always of 1 byte. It will reserve 1 byte only in the memory. We need to have these single quotes always. We cannot use double quotes because double quotes are reserved for strings, and in order for characters to work, we always need to use single quotes, and we can write any value here, any character here, and these character will be stored as it is. This 2 here is different than the integer or the floating or double, and if I write 1000 here, this 1000 is not this integer 1000. We can do certain operations, certain mathematical operations on this integer, floating data type or double data type, but we can certainly not do any mathematical operations on this character data type. So a character, this what I have written is here is wrong because a character can only be a one character only. This can only be a one single character. We cannot have these multiple characters stored into one location. So we need to have it, we need to make sure that it is enclosed in single quotes and have only one character inside it. So uh, we can, these data types you will see in your programming journey every time, and we can just simply print these values for now, and by using the cout insertion operator, and I can just go ahead and print first, which will be an integer, and then I can put some space here and use the insertion operator again to print second, and then again I will put some space here to write third, and same I will do for all of these, and like that, and there we will print the fifth, which is finally the character. And here the endl is basically putting a new line at the end, and it flushes the uh, it flushes the buffer of cout. This, if you're doing too many NLs, that might contain performance, that might cause performance issues. So more preferably is to use a syntax like this \n here, but we can use either of those if the program is simple. All right, let's run this program by clicking this button, or you can just go ahead and build this solution, and I can go ahead and start it without debugging because I don't want to debug this. There we go, and we have printed all these values. We can simply do many more stuff, much more complicated stuff with all these variables combined, and these will be very helpful in the future videos, as we will see. These are the these were the primitive data types in C++, and by combining those, we can do much more complex. We can solve much more complex problems, as we will see in our future videos. So this will be it for now, and I will see you in the next video. Thank you.